Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps to the world's best companies as quickly as possible. So in this lesson, we're going to harken back to those simpler days when we were learning just the if-then statement and the while loop and the for iteration statement. We'll talk about another decision statement called the select case decision statement. And then we're going to talk about a different data type that you can create called enumerations that limit the number of values that can be set for a given instance of that type. And then I'm going to show you how these two ideas kind of dovetail together nicely and how you can use them to work together to accomplish what you want in your applications. So if you recall way back in our discussion of the if, then, else statement in lesson number 7, I believe, we used a number of if, else if statements like so. If user value equals 1, then do this. Else if user value equals 2, then do something else. Else if user value equals 3, then do this other thing over here. Else, and this is the catch-all case, so do something in case none of those were true. And then we had finally an end if. Well, honestly, that syntax works just fine. But generally, if you have a lot of potential values that you want to evaluate, say 10 or 20 or even more values, then you can write the same intent more succinctly by using the select case statement instead of the if, else if, so on. So in this case, that we just talked about a moment ago, there are only 3 cases that we're checking for plus an else. But what if we had 10 or 20 or 30? Well, that passage of code would be really long, and you can shorten it up a little bit using the select case. So let's do this. We're going to create a new project called Using Select Case. And we'll create the following here. Okay, so I'm guessing that if you stared at this for just a moment, you could probably figure out how this works. However, in a moment, I'm going to explain a couple of aspects in more detail. So let's start running this to see the results. Type in a superhero's name to see his nickname. I'm going to type in Batman, and it returns Caped Crusader. All right, and I could try the same thing with Green Lantern, Emerald Knight, and here I'm going to try Aquaman. Does not compute. Okay. Alrighty, so just to leave no stone unturned, we're evaluating the value of the user value variable. And we see a very succinct syntax that allows us to evaluate, again, several known possibilities. Could it be Batman? Could it be set to Superman? Could it be set to Green Lantern? Also, I want to point out that we're using the 2-upper so that we're comparing apples to apples and oranges to oranges. Remember way back when we attempted to compare a lowercase word and an uppercase word, said if lowercase word equals uppercase word, then say true, else say false. And so we were able to see that in Visual Basic, strings that are have different cases but have the same basic letters, they are not equivalent. So we want to compare apples to apples. We're always going to do a 2-upper on any value that we retrieve from a user so that we can compare it against something we expect. All right. And just so you know, I mean, there's some indentation level here. This would be considered the code block that is contained by this particular case statement. So while we only have one line of code, we could have 10 lines, 20 lines of code, whatever it took until we hit the next case statement. All right, it's just that we have kept things simple here. Once we hit the evaluation of our case, no other cases are evaluated. So for example, if we were to run this and type in Batman and hit enter and start stepping through our code like so, we see it evaluates the case Batman and then it jumps all the way out to the end select and no longer will consider any additional cases, just as we might expect. Okay. Now there is a code snippet for this as well. If we typed in select and then tab, it creates this snippet for us. We can use again our tab key to go between the variable name that we're evaluating as well as the various cases using the tab and change those up if we like. It's not as useful in Visual Basic as it is in C# if you were to watch that version of this video, but still helpful nonetheless. All right. So what's the difference essentially between the if, then, else if, else, and if statement and this select case, whatever, and select statement? Well, in some situations, it can improve the clarity of your code, especially when there are many possible values that require an evaluation. In this simple example, because I don't want to type for several minutes, I just used 3 cases. It may not look all that impressive, but the if-then statement can handle more complex situations, and it's generally a bit more verbose whenever you need to evaluate many possible scenarios. But let me show you an example of where the if statement shines. I've created this project. It's available for you to download wherever you're currently streaming or where you originally downloaded this video from. It's called Complex If Statement. It's part of the Lesson 20 resources, probably in the After folder. And so here, let me just run the application. You can pick a number between 1 and 100, and it's going to tell you if you found one of the lucky numbers. So I'll type in 34 and hit enter on my keyboard, and it said you didn't find one of the special numbers. And if you take a look at the if statement here, notice that we're looking basically the compare value that the user types in to say whether if the value is less than 1 or greater than 100, then we'll give one message. If the compare value is equal to 42 or 23, or the number is greater than 90, then you found one of the special numbers. Otherwise, you didn't find one of the special numbers. So we're able to do some pretty complex and, ors, the else's, and we wouldn't be able to accomplish that in a select case, but we're able to do things, again, succinctly when there's a lot of potential values and they're rather simple in nature like we see here. Okay? So let's move on to another concept. I'm actually going to save this project and start by creating a new project called Understanding Enumerations as we kind of transition here. Enumerations. All right, enumerations are a data type, but they only allow a small list of possible values. Enumerations constrain the data, forcing it to comply to only one of several possibilities, and in so doing, make your code much more reliable. Generally, comparing magic strings like we've done up to this point, where we're comparing lowercase Batman to some magic string Batman that I've created, is a bad programming practice. We've accounted for that possibility in our example by using the toUpper method for string comparisons to ensure that we're comparing two strings that have a chance to match regardless of capitalization. But what about Green Lantern? As we saw previously, I think I've already closed it down, I have Green Lantern as 2 words. Is there a space between those 2 words? Is there no space? And so that's why often in the .NET Framework class library, the creators of the library force you to set some property value equal to an enumeration that they've defined. And you see them all over the place, and this prevents errors from occurring in your code. So for example, if I wanted to set, for example, the console's foreground color, notice that immediately when I use the equal sign, it pops open an enumeration called console color dot some color. And so I could choose, for example, red. Or if I were to type in console color, dot, it would show me all of the console color enumerations that were created. So somewhere there's a class defined as console color, and it's created a value for each of these colors we see represented here. And then foreground color, the property foreground color is of type console color, right? And so we can do this and console dot write line hello and console dot read line, and now we can see that we've turned the color, the foreground color, to red. So again, a small example, but this sort of thing is used all over the place. So when you see that a given property is set to, and you can see the definition here, public shared property foreground color as system.consoleColor is not string, can't I do this instead? Just type in, give it the color red? Well, no, I can't give it a string. After a moment, let's see if it'll accept that. No, it doesn't. Invalid cast exception. It can't figure out the string red and that you want to turn that into a type of console color. Right, so let's turn that back. Console color. Let's turn to red, like so. Okay, great. So the foreground color property, again, think of it this way. It's constrained to only offer viable colors. I can't just use the literal string red because foreground color is not of type string. It's of type enum console color. Somewhere there's an enumeration defined that's called console color in the .NET Framework base class library that defines all the possible color combinations allowed in the console .foreground color property. Again, the benefit is to you, the developer. It forces you to pick the correct value, and that leads to higher quality code. You can't make a mistake. It will find the mistake at the point of compilation. You might misspell the literal string red. I don't know. You might miss the E or the D, okay? And you might not catch that until runtime. However, using enumerations, that error would be caught at the time of compilation. So again, our goal here is to point out that sometimes you're going to deal with properties in the .NET Framework class library that are of some enumeration type that Microsoft created. So be aware of that. Pay attention to the IntelliSense, which will guide you in the right direction. Now, having said that, let me show you how to create your own custom enumerations in Visual Basic so you can better understand how this works, and yeah, maybe at some point you might even utilize them whenever you're creating your own frameworks, wherever you're creating your own classes and custom applications. So what I want to do is start by opening up the Solution Explorer, and I'm going to add a new class. And I will change the class eventually, but I'm going to start off by calling it superhero.vb. And by default, it has the name or the code snippet, public class and end class. And what I want to do is modify that and remove the class and use enum instead. Enum, like so. And now, let's see what this says. Enum superhero must contain at least one member. We're going to do it right now. Batman, Superman, Green Lantern. And we could add others if we wanted to, but let's just keep it kind of equal to what we did previously. And so when we go back into our module.vb and we start doing something like this, dim my value as superhero equals, oh, there you go. IntelliSense is pushing us towards one of those three values to initialize that my value variable. So very cool, right? So now what I want to do is rework that example from earlier where we allowed somebody to type in right line, type in a superhero's name to see his nickname. And what I'll do is I'll compare the literal string to one of the enumerations that we created in the superhero enum in the superhero.vb file. All right, so let me work on this for just a moment. Notice how IntelliSense helped me when as I was creating that case statement. giving me options to choose from there. With the code that we have so far, there's a little bit of an issue here. We retrieve a string called user value from the readLine method. However, we want to compare that user value string to my value, which is of type superhero. So how are we going to do that? Well, I'm going to need to add the following if-then statement around this. So if superhero dot tryparse, and I'm going to give it the user value. I'm going to give it, I'm going to use the second version of this, so I know I'm going to give it true and my value, and I'll come back and talk about this in just a moment. Then we'll wrap the else if around it like so. All right, and honestly, we won't even need this anymore, but I'll go ahead and leave that in there, okay? So let's talk about what's going on here in line number 13 here. So this is hardly a foolproof approach, but it does demonstrate this tryparse, which is a built-in method to enumerations. We're trying to parse a string, user value, into the data type superhero. All right, so this tryparse is either going to return a true or false. You can see it returns as Boolean all the way there on the right-hand side. That means it's either going to return true or false, that we were able to successfully find a match between whatever the user typed in and one of our superhero enumeration values, either Batman, Superman, or Green Lantern. So if it's true, then we're going to take the value, the superhero enumeration value, and compare and say, well, which one did they use? And then fire off the appropriate code block as a result. However, if tryparse returns false, they typed in Aquaman. Tryparse can't find a match. The else statement will fire, unable to find a superhero by that name. So tryparse will return true or false depending on whether it was able to successfully find a match. Now this middle, you can see here as we go, let's see, tryparse, let's see, yes, ignore case, true. We don't want to evaluate the case. So if somebody types in all lowercase letters or all uppercase, we're not going to factor that in. We want to ignore the case whenever we're evaluating our literal string against the enumeration name, okay? So if we start debugging this application and we type in Superman and we see Man of Steel. So what's the real benefit here? I mean, it still seems a little bit on the fragile side, right? Well, yes, it is a risky proposition because now we're relying on our users to type in the exact value. This might not be the best way to use the select case, but it does illustrate what it does, all right? But the value here is that I'm moving away from relying on literal strings, comparing literal strings together. And I can rely on the fact that whatever the user types in will match one of the enumerated values. And if it doesn't, then we can catch it here, all right? So again, we're not working with unreliable magic strings. We're working with strong types within our code. And that's really what I wanted to get at with the select case and the tryparse. Okay, so let's recap what we talked about in this lesson. We started off by talking about the select case statement, another decision statement. It's a little bit more succinct, but not as flexible as the if, then, else if style syntax that we've been using up until this point. However, it does great whenever you have a long list of potential values and you want to do something slightly different for each case. Then we looked at enumerations, especially those that we see in the .NET Framework class library. We use this as an example, but I promise you they are all over the place in the .NET Framework class library. Again, the value is that it restricts possible values that you can set a given property to, and that's a good thing. Restriction in code is a good thing because it ensures that your code is of higher quality. Then, just to prove how all this works, we created our own enumeration of type superhero, and we showed how to combine our enumeration with the select case. We used the Tryparse method to attempt to convert a string into enum values that we created. If it works, the Tryparse returns true, which allows us to evaluate against our select case statement. If Tryparse is false, then we're able to catch it in an else statement, right? So that's all that I've got to say for this lesson. We're working our way through this. You're doing great. Hang in there. I think the hard part's over. Well, I take that back. The next lesson is going to be pretty tricky too. We'll see you there. Thank you.